So thanks for joining, everyone. We'll get started in a few minutes. All right. Hi, everyone. Thanks for joining for this Kubernetes training. It's 11 a.m., so let's get started. So one quick note I want to make before we dive into the content. So I have Ritesh Patel, my co-founder at Nirmata, here as a panelist, and he will be answering questions on the Q&A panel. So if you have not already, please take a look at if you hover on the Zoom panel, you should be able to find the Q&A. And you can then type in questions as we're going through various content directly in the Q&A panel, and Ritesh will be answering them live. We will, based on time, we will also pause towards the end and see if we have more time for Q&A. All right, so just to kind of set the context and stage, in the last few years, it's an amazing time to be in the tech space. So if you think about it, everything that we have been doing in terms of software, in terms of how we build software, how we deliver software, and how we also deploy and consume software has been changing. And for the better, right? So some of the best practices that we've seen happen and get established in just the last, again, few years is moving more to a DevOps type of culture, moving away from, treating infrastructure as kind of more as pets into where infrastructure becomes commodity, moving to containers and immutable images. And now with technologies like Kubernetes, which we're going to talk about today, moving towards standard platforms which let us build, deliver, and operate cloud-native software. And the whole goal of this, of course, every business today is becoming more and more digital and is dependent on software, and businesses are being driven to innovate faster and get into this loop of continuous innovation. So today we're going to focus on Kubernetes, which we believe is a core enabler of this digital transformation. And what we're going to cover is the basic concepts in Kubernetes for building and operating Kubernetes clusters, as well as we'll look at the main concepts on the application side. We'll do a quick demo, again, based on time, for both the cluster side of things as well as the application. And then we'll come back for a summary. And along the way, like I mentioned, please do enter in your questions in the Q&A panel, and we'll be answering questions live. All right, so before we dive into the details, just, all of you who signed up, you did, and there was one question that we asked, so just to kind of, so you know the pulse of the audience. It's amazing to see that most of you are actively learning and using Kubernetes. A few folks are just, getting introduced to Kubernetes, which is great as well. But what we'll do today is we'll keep this very fast-paced, and we'll go through a lot of, the core concepts in the short amount of time we have, so you all get familiar with this and can start deploying and operating clusters as well as managing applications on Kubernetes. Just a quick note about myself. I'm Jim Bagwadia. I'm the founder and CEO at Nirmata. And all of us, myself, Ritesh, who's my co-founder, and others at Nirmata, we're all software developers. So we're building solutions around Kubernetes, around containers, which we believe that other software developers, as well as, of course, folks in the operations and management field would want. So that's kind of our mission and what we're doing here at Nirmata. So going towards Kubernetes and starting first with some basics about what what Kubernetes is, right? So if you go and if you read the charter on the CNCF, the Cloud Native Compute Foundation website, there's three attributes that they highlight for cloud native software. The first is that the software is container packaged. The second is it's dynamically managed. And the last is that it's microservices oriented. And what Kubernetes does is it allows you to manage containerized applications, right? So mostly it fits into the second bullet, but it also enables the microservices style of application development and operations. And of course, it's built for container packaged applications specifically. And if if you've seen all the buzz, and again, like look at CNCF today, the other aspect about Kubernetes is it's very much community driven. It has a lot of users who are part of this community as well. And this is what's great, that people are sharing and learning from best practices as we're building and architecting these cloud native systems. So quick definition, Kubernetes is just an open source system for automating the deployment, scaling, and managing containerized applications. Now, they don't necessarily need to be microservices oriented. There are, you might have applications which are stateful, which are very traditional three-tier type of applications, and Kubernetes can manage these as well. So although the aspirational goal for cloud native software is to move towards microservices, that doesn't have to be the starting point, or what you can also bring your traditional and existing applications and manage them with Kubernetes. So Kubernetes came out of a lot of the best practices, a lot of the lessons learned at Google, from their experience of 15 plus years of managing containerized applications. This was, within a system that they internally used as called Borg. And there's a new version of this called Omega, and Kubernetes kind of takes all of this and has made it more consumable, I guess, for cloud native workloads, and really builds on some of these patterns and best practices that they learned. Although Kubernetes was originally developed by Google, it is now part of the CNCF, which is a part of the Linux foundations themselves. And it is a community-driven effort. There's folks from several companies, large and small, several users who also contribute to Kubernetes, which is what makes it so great and so powerful in terms of its extensibility and future. One thing to remember, and this is Joe Beda, who's one of the founders of Kubernetes, he said, it's basically Kubernetes is intended to be a toolbox, right? And it's really not intended to be an end product that you directly consume. And the power of Kubernetes comes with what you build on it, or what you can build on it. So that's a very good recommendation to keep in mind as you're approaching Kubernetes and learning about the concepts there. Okay, so let's dive into the cluster part of Kubernetes, and then we'll look at, after that, we'll look at how you model, deploy applications on Kubernetes. So some basics on the cluster. There's four major components or things to think about. The first are nodes, which are just virtual or physical machines where you're running both your applications as well as the Kubernetes components. The next are components themselves. And there's various Kubernetes services, if you will, or pieces of software that you would be running on your master nodes as well as your worker nodes. The third item here is add-ons, right? So to make your cluster complete, you will need things like DNS services. You might need monitoring services. You might want to use a dashboard, which is used to, to be able to view and manage your cluster. So these are considered add-ons. And then finally, Kubernetes integrates with every major cloud provider. And there's, of course, you can customize this yourself. And this is where the networking, the storage, security, and other infrastructure policies for Kubernetes are provided through this cloud provider integration. So the basics here are you have master nodes, you have worker nodes, you have components running on these nodes, and we'll take a look at what those are. You have add-ons to make your cluster complete, and then you have your cloud provider integrations for networking, storage, etc. So on the master, some of the important components, so that there's four major components that you will always have, and then there's etcd, which acts as a data store for your cluster itself. So Kube API server is the main component that everything else communicates with. And this is where you do things like admission control, RBAC. So this is an extremely important component, which typically in a production cluster, you'll be running multiple instances of. In a dev test cluster, or if you're running Kubernetes in Minikube on your laptop, you will have a single instance of this. Then there is multiple controller managers. So there's the kube controller manager and cloud controller. So one thing to quickly highlight, in Kubernetes, a very common pattern is to have control loops which manage specific behaviors for your cluster. And really, if you think about it, a control loop, just like in software or even in hardware or firmware programming, a control loop is nothing but like checking the desired state of your system, and then making sure that your current state moves towards your desired state. So in the kube controller manager, which is deployed as a single component or a single container, if you're running Kubernetes in containers, there's about 14 or 50 plus different controllers which are coordinating different states within your cluster. So this could be everything from things like scheduling pods to looking at deployments and making sure that the correct amount of replicas are running. All of these are running as controllers, as control loops really within this controller manager. There's also another controller manager which is specific to cloud providers, and this was split out of the main controller manager for modularity, and so it can be upgraded and managed separately. And then there's the scheduler, which is another controller, which again is a specific purpose, and its role in life, its job is to assign pods to nodes as nodes and pods become available for scheduling. The scheduler is what actually finds the right pod and assigns, or finds the right node and assigns the pod to it. And then, I already mentioned etcd, but it's worth mentioning again. So all of the cluster state is stored in etcd by default, which is a key value store. And this is it's a distributed database, which again, you can run with multiple replicas for production. And you can run etcd on the same, on your master nodes itself within your cluster, or you can have a shared etcd that you're pointing to as you're operating your cluster. All right, so we talked about what is on the master nodes, but now let's talk about what goes on each worker node. So each worker node at least has to run three things: a kubelet, which is what connects to the API server and gets instructions from the API server in terms of what needs to happen for scheduling and management. A kube proxy, which does the networking for the components on the node itself and across your cluster. And then the container engine, which could be the Docker engine, or it could be other engines like Containerd or even Rocket, which are actually managing containers on that particular node. On the worker nodes also, optionally, you will have your add-ons. You could have things like, Fluentd for log aggregation, several other tools that are common services that you might be running. And then you would have your application pods or your application components itself, which are running. So here I mentioned, pods, and it's a good time to introduce this concept of a pod. So in Kubernetes, the basic unit of management, the basic unit of packaging, deployment, upgrade, operations is something that's known as a pod. And this is one of the best practices, like we were talking about, coming out of the experience that Google had running containers at scale, where they didn't want to limit the unit of management or make the unit of management a single container. The pattern that they found that worked really well is to have a pod which is tightly coupled containers, which can share some storage and networking. So think of it as a mini VM to some degree, where they're sharing some storage, sharing networking, sharing a life cycle. And all of these pods, can now intercommunicate. So say, for example, in your app, if you have specific needs, like even you want to make sure that you're leveraging or accessing certain services through just a local port, you can do that in a pod. If you want to use IPC for shared memory communication, you can do that in a pod. So things which just containers make, sometimes make difficult to do, a pod can solve. There's also several patterns for distributed applications. Like you might, to keep things very modular and microservices oriented, within a pod, you might have one main function or one main service, but then other helper services which can be integrating with external components. So this gives a lot of flexibility and introduces a lot of interesting patterns that you can use to build your distributed applications. All right, so going back to the worker nodes and what's on each worker node. So we talked about, you have your kubelet and your kube proxy, the kubelet connecting to the API server, the kube proxy for your networking on the worker node. But you can also have add-ons, and it's very, any cluster that you're deploying managing applications to, you will at least want the DNS add-on for service discovery and for services to find each other through names, because it's an anti-pattern to be referring directly to IP addresses, of course, and at any scale you will be getting dynamically assigned IP addressing. So DNS is almost always present, and it is an add-on which you will want on your cluster. Heapster is another very common add-on, and what this does, this is actually now exposed in 1.9 through the metrics API. So it provides an engine for collecting basic resource statistics. It also has a way where you can push your own custom statistics, and then you can consume these stats through the metrics API for monitoring and management. In fact, some of the Kubernetes controllers, like the HPA or horizontal pod autoscaling, uses the metrics API now to be able to perform some core functions like autoscaling within your cluster. And then optionally, you can install the web UI, or you can use other tools like kubectl, which is a CLI-based tool, or tools like Nirmata to manage and operate your clusters. Okay, so a very quick, I just have a couple of slides on networking. This itself is it could be its own talk. There's enough content there. But just to introduce Kubernetes networking, there's three basic principles or three fundamentals to remember. First off, in Kubernetes, all containers can communicate with all other containers in your cluster without NAT. And of course, there's security rules and things you can use to control who talks to who. But by default, if you don't have any of the security network policies configured, every container will be able to talk to every other container without NAT or bridge networking or anything like that. Also, all nodes can communicate with all other containers without NAT. and which means that the container networking and the node networking is flat. It's it's at the basically at the same level, and they can communicate just directly with layer 3. And then the IP that the container sees is always the same as the IP that others outside the container see. So once again, these are three best practices that are quite different than if you're familiar with Docker networking. It's a different approach that Docker took to networking, but some of the lessons learned at scale from Google led to these three best practices as being the foundation of networking in Kubernetes. So the simple thing to remember as users, so each pod basically gets its own IP address. You would use DNS to address a group of pods, and we'll see how you would group pods together. CNI is a networking plugin that's used, by kubelets, and it works with, a kube proxy, which is a TCP proxy for networking. And there's several implementations: Flannel, Calico, Contiv, as well as cloud provider specific integrations for the CNI plugin. So pretty simple from a user perspective, and solves a lot of, doesn't introduce like some of the challenges that we've seen with other container networking, makes it really easy to build and manage these networks. Okay, so quick, discussion on storage, and then we'll move to other topics in terms of building and deploying applications. So in Kubernetes, each pod, so remember a pod is a group of containers with the same life cycle. So your application will have several pods, and each pod can contain one or more volumes. Volumes can be as simple as an empty directory if you basically just want a temporary directory, which is deleted or goes away when the container or your pod goes away. It could be a host path, which means that there's some data that can be stored on your hosts. It could be something like a secret, which is an encrypted piece of information that your application uses. Or could be an EBS if you're using AWS, and Azure Disk, a file system. So it could be several things. There's also one very interesting type of volume, which is something called a persistent volume claim. And what this is, it's kind of a way for a pod to request a volume which does not already exist. And what will happen is when that pod gets scheduled, the persistent volume claim for that pod will also be then scheduled and fulfilled. So based on your backend storage class, so if you've configured, for example, EBS on your cluster, and EBS disk will get created, and that will get attached to your pod so that that can be consumed. So it's interesting, so this gives you the ability to dynamically create volumes for your workloads, and also based on the claim to be able to reattach volumes to pods as needed. So that opens up a lot of interesting possibilities for even stateful workloads, where you want to manage the disk state, your persistent state, and you don't want to lose that when your services go away, or if you want to redeploy everything, you can do that and still retain your persistent state. And we'll talk more about this as we look at the application concepts itself, which is the next section, right? So far what we have done is we talked about, the main of what makes up a Kubernetes cluster. We talked about the master nodes, the worker nodes, the various components like Kube API server, as well as the schedulers and the controllers, which run on the master, the kubelet and proxy, which run on the worker nodes, and what all of these, what the main functions for each one of these are. We also very quickly covered networking and storage, just so that we get a quick understanding of how Kubernetes networking works and what some of the storage options are. But next, let's talk about, what all of this is for, right? So the goal of Kubernetes is, of course, for us to build, deploy, operate cloud native applications. So let's look at what it takes to do that, and what concepts and in the Kubernetes toolbox exists for us to build these applications. So just to start with, I mean, there's a lot, right? So this is where Kubernetes can come across as being slightly intimidating initially. There's a lot of different concepts, there's a lot to choose from, but each one has a very specific purpose. And by the end of this section, you will know exactly, what to use for different types of applications, etc. So the main thing to talk about first is, there is a concept of a namespace. And I'm not going to cover isolation and how you would isolate and segregate resources in much detail today. But it's important to know that your application should live within a namespace. Now, you might choose to have a namespace per team, per environment. One best practice that we have found is starting with a namespace per application or running application instance, because what that lets you do is now you can have several instances of the same application running in the same cluster, which is great for like dev tests and shared environments. Otherwise, you're restricted to, because of naming collisions, you're restricted to running only a single instance of an application within a cluster, which can be a hassle or a hindrance based on how you're sharing this. So namespaces are important, but then let's talk about some of these other concepts and some of these items as we go through. So first off, we already, I introduced pods earlier because that's a very fundamental concept. So once again, a pod is the basic unit of deployment operations in Kubernetes, but it's also the basic unit of how you would package your application components. So in the simplest form, each one of your containers becomes, a pod, where you might have, most of your pods may just have a single container. But as you see, with distributed application lifecycles and with service lifecycles, you will start seeing that there are useful patterns to introducing helper containers or containers which can pull data, containers which can do initialization and setup, things like that. And these could be separate from your main application in your pod. So a pod consists of multiple containers. It can also have things like PVCs, persistent volume claims for storage. And there's several other things you can do as you're defining and managing pods. So you could have node selectors for if you want your pods to live on specific types of nodes or hosts. You could have affinity and anti-affinity across pods. So if you want certain services to be closer together as part of your application, you could do that. Each pod also runs with a secure service account. So you can have an identity really for a pod. And this is where, as your application may need to sometimes pull things or look at other things within your cluster, that service account is what's used to do the authentication and authorization for your application components running in a pod. You might have secrets, which are, again, confidential information for your application. These are encrypted and then made available. So they are encrypted in etcd at rest based on your settings. And then these would be made available within your pod, either as a volume, or you could map them to environment variables if you so wish. And then you can also have initialization containers. So these are things where if you just quickly want to maybe even do something like grabbing a license for your service when the service first comes up, you can do that in an init container. And then when the pod is released, you can write a controller to free up that license, or you could make that as part of your shutdown in terms of your life cycle of your pod. So it is possible in Kubernetes, and Kubernetes allows a lot of flexibility in how you do things. So it is possible that you can, just package your application as pods, and then you can deploy, operate, and manage your pods individually. But really, that will be, losing a lot of value that Kubernetes can provide, right? So don't. I mean, it's great to play around with if you're getting started, but don't. Typically, you would want to use some of the higher level constructs and not use pods directly when you're deploying applications. So to manage the lifecycle of a pod, I'm going to talk about three concepts in Kubernetes. There are others, but they're not that commonly used. So the three concepts I'm going to cover are deployments, which is probably used the majority of the times to manage pod lifecycles. Stateful sets, which is also very important, especially for traditional applications or stateful applications like databases, etc. And then daemon sets. So these are three high-level concepts you can use to manage pod lifecycles. So let's start with deployments. So deployments, like the name itself indicates, they are used to deploy a set of pods, and you use deployments to manage the life cycle, which would be things like upgrades, rollout, rollbacks for these pods. And deployments give you a lot of flexibility in terms of upgrade strategies. So there's things like a rolling upgrade strategy. You can even configure what percent of your services can be down at any given point. So you could do something like have a policy to say 25% of my services can be down, but not anymore. So what this means is, let's assume if you have, of course, like 4 services running, then you would have 1 service down at any given point, and Kubernetes will bring up a new service before then turning off additional services, right? So lots of tunables and flexibility in terms of how you can manage that rollout, upgrades, as well as scaling your set of pods up or down for which are providing a service. One thing to quickly mention, right? So the assumption is that if you're using microservices style applications, so each component, each service in your application may have several pods which are providing the same service, right? And you're doing this for replication, you're doing this for availability and scale. So you might be running, let's say, 3 instances of each pod for a particular service. So, and this could be, let's say you have a web tier, you're running 3 instances of that. So as you're upgrading your web tier, now Kubernetes will use the rollout strategy, the upgrade strategy, to make sure that it's upgraded correctly. And it will integrate into things like the probes, which are health checks for your container to make sure that your services are running correctly. The other major concept or way to manage pods is through stateful sets. And once again, like this name indicates, these are pods with some state. Now, state comes in many different forms. It could be persistent state, which is very common, but it could also be an identity, a name that means something to your application. And that name, once maybe you have a binding between clients and servers within your application, you want that name to remain the same, regardless of what happens, how you're upgrading or scaling your application. So think about stateful sets as basically pods with stable identities. And these could be names, this could be network addresses, this could be storage. So things which need to be managed as state for your application itself. And what's different between state deployments and stateful sets is deployments, the pods can get scheduled on any node. They will, they will be managed, dynamically by Kubernetes, and they will be scaled appropriately based on your replica count, etc. With stateful sets, there's a little bit more structure. So there's ordered creation, ordered updates, and there's policies to override this if you don't care for ordered creation and updates. But even scaling and deletion will happen in a particular sequence, which makes sure that, again, if there's names that other components are referring to, there's always one, that one of those names available, so your application doesn't have an outage. A great example of when to use stateful sets is something like if you have a Zookeeper cluster, which, let's say in this example, you have 3 nodes, and each one is running, the same port in different pods. But you want, you have Zookeeper 1, Zookeeper 2, Zookeeper 3, and your clients are binding to a list of connections using those, those DNS names. So you want to make sure that there's always, those 3 names exist. Even if you scale up and down, you have some stable identity over there. The last way of managing pods that I'm going to cover is something called Daemon Sets. And Daemon Sets are, are something you would use when you want to run a pod on each node of your cluster. So this is great for things which need to, for example, If you have an agent which needs to run on every cluster, if you have a security service which needs to run on one on each node, and even things like, if you're running, like, for example, a log aggregator, stuff like that, that you want to make sure it's replicated on every node. Even when you bring in a new node into your cluster, if you've configured this as a service as a daemon set, or a component as a daemon set, then it will automatically bring up a pod on that particular node itself. Now there is more fine-grained control as always, so you can use node selectors to target a subset, but typically daemon sets are great if you want to make sure there's one instance, one pod running on every node. All right, so we talked about pods, and then using deployments, stateful sets, and daemon sets to manage pods. And now let's talk about what we have to do to network our application, and then we'll also cover storage. So there's three concepts to think about for networking your application, and those three are: you can define something known as a service. So a service is what allows other pods or other components within your application to be able to address or direct traffic towards your component without having to rely on pod IP addresses, right? Because pods can come and go, pods can be rescheduled. So think of a service as providing a stable identity for your set of pods for your application service. You can also define a network policy or several network policies for your component. And a network policy is nothing but ingress and egress rules which define how services or how application components can intercommunicate with each other. And finally, you can define an ingress, which defines how external traffic can be routed into your component. So typically within an application, you might have a few services which act as ingresses. So this is your API endpoints, things which are like, maybe your web servers, things like that can be your ingress, or you would have ingress rules which are configured to point to these. And then you can have, other components which are just communicating east-west or in a horizontal manner within your application, and you would use network policies to manage that communication. And service is what gives your set of pods an identity which other services can look up and can rely on, right? So those are the three things you would use for networking. And we'll take a look at this live in an example to see, how, like, so let's say a classic example is if you had e-commerce type of application, you might have a catalog service and a customer service, and each service may have several pods. And then you have network policies which define, can the catalog and customer talk to each other? You might have, another which is like let's say your web app service, which has an ingress rule pointing to it, and that's how you would structure your application. So very quickly on the storage and bringing storage to your application, like we talked about earlier, a pod can have one or more volumes, and these volumes can be dynamically created or statically created. Typically, you would want them to be dynamically created just for, to ease the lifecycle management. So these volumes, the administrator, whoever's setting up and managing the cluster, can define the storage classes and can define how these volumes can get created. And then you would submit a persistent volume claim in as part of your pod. So that could be a disk type, which would then bind itself to a persistent volume. If it doesn't exist, it will go ahead and create a persistent volume and then associate it to that pod. All right, so let's quickly cover, I know we went through a lot of different concepts on the application side. So I want to kind of show how these come together, right? So the basic unit, what as developers, or if you're an operator, what your developers will care about most is how do you define what goes inside a pod, right? So what are your container images, which versions, what ports, things like that. So the basics go into that pod spec or the pod definition itself. Beyond that, you're most likely going to use a deployment or stateful set to manage your application pods. Now, you could use a daemon set, but those are more for like vendor tools, third-party tools. So typically you would use a deployment or a stateful set. Next, you're going to define a service which provides identity to your set of pods. So as your pods come and go, you have like a well-known name. You might also have a cluster IP, so an IP address where that service can be referred to. Kubernetes will automatically load balance to your available pod based on your probes and your health checks, which are configured. Next, you could define network policies. So within your application, if you want certain services to talk, to each other and other services not to talk to each other, you would do that using network policies. And finally, you would define an ingress, which is what provides a path into your application from the outside. So this could be coming from external, internet traffic or other traffic from within your enterprise, of which your application is servicing. That is defined through ingress rules as far which URL paths or what types of traffic can be allowed into your application. So all of these, the pod, the deployment and stateful set, services, network policies, and ingress is typically what it takes to define one service within your application. Now, any normal application will have several services. So think about an application as a group of these services, and there's additional things you might want to add to your application. You could have PVCs defined, which are predefined as part of your application. You might also have things like secrets, which are part of your application. So things like passwords or even SSL keys and certificates that you might want to store as secrets. And then config maps. So if you want certain configuration to be part of your application, you can now put that in and share that within different services or pods as part of your overall application. So think about an application as a collection of services with some rules for how services can talk to each other, and then additional things like config maps, secrets, and persistent volume claims as needed. All right, so far what we've done is we've covered the basic concepts of what it takes, for a Kubernetes cluster, to build a Kubernetes cluster, what components go on the master nodes, on the worker nodes. We also covered, application concepts like pods, deployments, stateful sets, and other concepts like secrets and config maps, which it takes to build an entire application. And now what I want to do is kind of switch to showing some of this live. And then we'll see, I will go back and see if there's additional Q&A beyond what Ritesh is already answering. So if you've joined late, please do put in your questions into the Q&A panel. And Ritesh, one of our panelists, is answering these live as the questions come up. And then we'll see if we have additional time towards the end. So before I jump into the demo, so I am going to use Nirmata to do the demo. So just want to quickly introduce what we do at Nirmata. So we are a Kubernetes-based application platform, and Nirmata is delivered as a service, or you can also deploy and manage this Nirmata on premises. And our background, myself, Ritesh, others at Nirmata, we come from a background of managing complex distributed systems, and we build these centralized management systems, which is what we're now bringing into the application space as applications get cloud native and more hyper distributed. So just very quickly on what Nirmata does, and then we'll switch to looking at the Kubernetes cluster live and also managing applications there. So first off, a Kubernetes cluster, as we saw, is also a distributed application, right? So there's several components on masters and worker nodes, and these need to be managed. Typical enterprises have several clusters, maybe they're based on lifecycle, like dev test, staging, production, or maybe different teams run their own isolated clusters. So Nirmata can help manage the cluster components. It can install and operate Kubernetes for you on any public or private cloud. And it also can manage the lifecycle of the nodes. So the cloud provider instances or virtual machine instances, Nirmata can spin up and spin down as needed by your cluster. But most importantly, what Nirmata does is it provides, application management for Kubernetes workloads, everything from modeling applications to be able to deploy applications on your clusters, you having policies for common behaviors for applications, and then also providing policies for the governance and lifecycle management of these apps. So let's switch to looking at this live, right? And then we'll come back for a quick summary section. So I'm going to share, to start with, what I'm going to do is show a cluster that I'm using. And so let me switch to a different window. And here what I have in my, oops, I'm going to shut down some of these screens. Here what I have, and I'll make this a little bit larger, is I have a 3-node cluster that I created using Azure. So this is a Azure Kubernetes Service and AKS cluster. If I look at the namespaces running on it, I have some standard namespaces. And I have also, if I look at pods right now, there's no pods running on this cluster, right? So the first thing I'm going to do is I'm going to get this cluster to be something that we can manage in Nirmata, right? And then we're going to see how to deploy applications on this itself. So I'm going to go into the cluster section here, and I'm going to say I'm going to add a new cluster. We're going to select Kubernetes as a type, and since it's already running, I don't want Nirmata to install Kubernetes, but I'm just going to import in this cluster. So I'm going to call it Azure Kube, and I'm not gonna give it an endpoint right now, but what I'm gonna do is I'm gonna download this YAML file, which is what Nirmata generates, right? So now I'll just quickly open this and show you what this looks like. So once Nirmata, has the binding for the cluster, there's a YAML file, which is, so most Kubernetes manifests you can either manage as YAML files or JSON files. This is a YAML file you will install in your cluster to be able to now get Nirmata to manage it, right? So let's quickly do that. I'm going to go and on my CLI, I'm just going to say kube control create -f and point it to the YAML file we just downloaded. And what that will do is it's going to import a couple of constructs. It's going to import an agent as a daemon set, and then a deployment, which is a controller. And because I've used this cluster before, it's telling me some namespaces and things already exist, but that's okay, right? So now what I'm going to do is I'm going to say, I will say -n namespace, or I want to give Nirmata as the namespace and do a get pods, just to see what's running on this. And we see already that a few things have come up, right? So going back in here, I'm going to say I've already connected my cluster, and we'll just jump into my cluster panel, which is this new cluster that I just created right now, right? So at this point, the controller hasn't connected back yet, but what we'll see in a few seconds is that the controller will connect back to Nirmata. And at that point, if I browse through in Nirmata itself, I can see exactly what pods are running. I can see which namespaces are created, any storage class, things like that for my in my cluster itself, right? So this is providing a very simple view of the cluster. But the next step here is what we want to do is to be able to use this cluster in terms of being able to deploy applications and environments or applications, right? So to do that, what I would do is I would create an environment. And an environment, you can associate a namespace with an environment, or you can associate namespaces with specific applications, like I mentioned. And then each cluster can host several environments. So this is a logical concept. And you can now have teams, with RBAC bindings, you can have teams share an environment as you wish within Nirmata. So here I'm just going to create an environment, and at this point there's no applications in it, but you can see if I go into my settings that I can manage how I want CI/CD updates to flow, as well as how I want access control, right? But let's switch to what we can do to model an application, and I'm going to quickly show you that in terms of a new application itself, right? So the first thing I will do in over here is I have an existing application in my catalog, and as I drill down into it, you can see this application has 4 services. And if I drill further down, I can see beyond the services, there's a deployment here, which is model. And there's a pod also, and this pod contains a single container, and there's no volumes in my pod, right? So if I go back up into this, for this application itself, what I'm going to see is in this blueprint, this application that I created, I can actually export this as a set of Kubernetes YAMLs. So if I want to deploy this directly myself using kubectl, I can see exactly what, and for each one of these 4 components in my application, I have a deployment for each one. I have network policies for each one. I have a service for each one. And then I might have things like a config map, which are common and which are shared within this application itself, right? So this is how you can model a very, an application, which it could be very simple. You could start with a very simple YAML, or you could model a fairly complex application very quickly and then generate all the right Kubernetes constructs in Nirmata. So the next thing I'm going to show, I mean, of course, so far we've just modeled the application, but now what I want to do is I want to create a new instance of this application in my cluster. And because we're using namespaces per running instance, I can go ahead and have multiple instances. So I'm just going to say run over here. And now I see it went into the environment that I chose. And this environment, once again, maps to a particular cluster, which happens to be the Azure production. We've just named it Azure production. And now I see that Nirmata is bringing up my services, and it's each service is going to go through its life cycle, and once it responds to a health check, then the service is up and running, right? So in a few seconds, we should see my entire application is up and running. And at this point, I can even manage things like, say, for example, for whatever reason, a service happens to disappear or fail. Of course, Kubernetes will reschedule it, but what this will also do, like if I kill a container and if my image pull policy is set to always pull, there will be a new version deployed or a new instance, and it will reconcile in a few seconds, right? So what I can also do is, so it's saying that it failed and then it switched to running right away. So by the way, everything we do in Nirmata is also logged as an audit trail. So this is, because we just created this environment, there isn't much here, but you can see that as an audit trail. We also get, real-time analytics that shows that, hey, this container died and then it came right back up. So one interesting thing is when you start using Kubernetes and containers, is things happen and the system recovers from it automatically, right? So how do you troubleshoot, let's say every day, maybe you have a Java application which happens to, run out of memory on the heap size and gets restarted right away. Your service is not going to take much of an outage, but it's important to know this. And this is the type of, analytics you need to be able to see if your containers failed and what exactly happened. You can also, like, of course, if you want to manage things like scale, you can scale services up and down. You can manage image upgrades, all of this very easily from this console itself, right? So I'm not going to go into too much detail here in terms of showing a Nirmata demo, but just to kind of give you a feel for what it looks like to manage applications. There's also several policies you can configure, like we said, for things like config maps, secrets, which one interesting challenge is your secrets are dependent on each environment, right? So you don't want the same secret to be in dev test and in production. So you want those to be injected at the right time when your application gets deployed. So that's a very quick tour. What we just saw is, we discovered a cluster and we were able to deploy an application to it. We saw how to model an application. I can also, what I did not show, but if I want to just import a simple application, I can import this, as a set of YAML files. So for example, if I, have a YAML file for a particular application, I would drop it in here and give it a name, and that would just import that particular YAML file into my catalog itself to be able to manage. But okay, so that was the quick demo, and let's switch back and kind of summarize what we've learned so far, and then look at, if there's any questions we want to answer live. So really, the things to mention here is that there's, three key takeaways, right? So every enterprise, obviously, as we're moving into this new era of software, as software is being deployed, operated as cloud native, every enterprise needs to move faster and kind of make these life cycles, the innovation loop faster. So cloud native technologies are being adopted mainly for that reason. And Kubernetes is one of the underpinnings, or perhaps the best way out there right now to manage containers at scale. So assuming you're looking at adopting containers for your existing apps or for your net new cloud native apps, Kubernetes is something that you would want to take a very close look at and potentially use to manage these containers. And then what we looked at from just a very quick Nirmata overview is Kubernetes itself is a tool set. So like we discussed in the introduction and as we went through the training, you need some way of deploying and operating Kubernetes clusters on various cloud providers. And you also want some ways to make sure that you have common policies, some common ways of defining and managing applications. And that's what tools like Nirmata and others in the Kubernetes ecosystem will help provide, right? So you want to look at both tools underneath Kubernetes and tools on top of Kubernetes to complete your whole application lifecycle management. So in terms of what you could do, where we go from here, so certainly my email is jim@nirmata. Would love to hear from all of you whether this training was helpful, if there's other topics you would like to see covered in future sessions. Just reach out and connect however you wish. You can also, if you want to try out Nirmata, just go to try.nirmata.io. We have a free 30-day trial you can sign up for. And we're always, even if you don't end up using Nirmata, we'd love to hear and get feedback. So definitely give it a try and see what you can do with it, and let us know where we can improve and what other things we can do. So with that, let's see if there's any questions we want to answer live. So, Ish?
Yeah, there have been several questions, and I answered a few of them along the way, but I left a few towards the end because they were more general. So one is on stateful sets. So how does a stateful set reattach to a volume in case of failure? And will the volume for stateful set be created on the same host node or a random node?
Yeah, so with stateful sets, they do have stable identities. So to answer the second question first, it would be on the same node if it has the same identity. And then, based on how your volume is provisioned, let's say if you're using a PVC, that same PVC will be used to reattach to that volume. Right, so the claim number will identify the volume, which then, if that volume still exists and it hasn't been cleaned up or deleted, it will just get reattached to that stateful set pod.
Okay. There's another question again on volumes. So do volumes ever get subdivided up, or does the administrator have to deal with sizing before registering?
So this depends on the type of storage you're using, right? So there are different attributes based on the different storage providers. So let's say, for example, if you're using a storage array which allows virtual volume sizing, you would just specify an initial size. Others, like if you're using things like EBS, etc., you can just specify the disk size. But typically, you're not subdividing volumes. Think of each one of this already as a virtual volume, if you will, which a cloud provider will support or your storage array will support. And that virtual volume then gets attached to your pod, and it's used only by that pod. Now, it is possible through permissions that multiple pods read can read different volumes. So if you want like read-only access across pods, you can do that. But then you have to make sure that that storage type can support having multiple readers or multiple writers. If you're using a file system, both can be supported, and that works really well. If you're using block storage, then you would have to handle that based on your storage class type.
Yeah, and we have a couple of questions on ingress and load balancer. So does ingress work for TCP ports or only HTTP ports? And if so, on Minikube, how do I expose TCP port to the outside?
Yeah, it's a great question, right? And yeah, so it does work on both TCP as well as HTTP. So you can configure and both types of protocols. And you could use something. There is a node port for which you can use for your service if you want to just expose a service on a specific port on every particular node in your cluster. So that's one option if you want, like, let's say some well-known port to be used for a particular service on every node. You could do that. If you want to configure an ingress, you can also configure a node port for that basically for the service, and then just point your ingress to use that node port as it's as it's finding and talking to the service, right? So the ingress is an additional. Typically, there's an ingress controller like an Nginx or some sort of maybe an Envoy proxy or some load balancer which is talking to your service, and that's what you could use. Then you would point to the specific node port to be able to complete the full communication path.
Another one, this one is on pod networks. So concerning network ports between pods, do you need to explicitly define each port within your Docker containers to communicate across pods?
So it depends on your service. If you are exposing multiple ports, then yes, you would want to configure each one of these, to allow communication. If you like one simple way you can manage this is you could have a rule that just says allow all ingress from within my namespace and allow egress to all, right? So something simple like that is a great way of getting started. But typically when you're running several services in a production cluster, you might want more fine-grained control, and that's when you would define each port and who is allowed to be communicating on that port. But it's optional. It's up to you. You can make this coarse-grained or just allow all, or make it as fine-grained as you wish.
Yeah, I think we have a few more questions, but we're pretty much out of time at this point. So we'll respond online, and then yeah, and if there are more questions, please reach out to us on email.
All right. Thanks again, everyone, and hoping to hear from you. And just let us know again what you would like to see in future sessions and whether this webinar was useful or not. Thank you.